So let's get into this derivative stuff. 31, yeah, we'll go over 31. So the homework last time, like I said, it's page 118. I wanted you to do 7 through 25, odd, right? And then 31 to 53, odd. And so I did 31. Didn't I do 31 with you in the video? Should I go over 31 again, or do you want a different one? 33, 35. And what you want me to answer for that? That would be good, Lisette, but that's more of a personal education, not a calculus education. So I need the calculus test. All right. So again, what we talked about are derivative rules, the basic derivative rules. We had constant rule. The derivative ddx of any constant was 0. Any number, you do the derivative of a number, you get a 0. We had our power rule. The derivative of anything with an exponent is take the exponent in front and subtract 1 from the exponent in the top. That's our power rule. Okay. We had, what else did we have? We had constant power rule. We had the derivative for sine and cosine. Oh, we had the coefficients, right? Coefficient rule was the derivative of anything with a coefficient in front. Right? You have some constant c in front. You just leave the number in front alone and have the derivative of your equation. So it's a multiplication. The number stays in front. The number doesn't move. Coefficient rule, power rule, constant. We had our rule for adding and subtracting, addition subtraction rule. When you have multiple things, the derivative of some multiple things like f of x plus g of x, basically you distribute the derivative. You just do each piece independently. F prime plus g prime. Do each piece on their own. Addition, subtraction. Each piece gets done on their own. And the last rule was for sine and cosine. The derivative of each one is the other. The derivative of the sine of x was the cosine. And the derivative of the cosine, that was negative sine. The cosine is negative. Anyone with a c, your derivative becomes a negative. Just sort of how that works. So these rules, these fundamental rules, help us to quickly do derivatives of some complicated equations. And so we had things like number 31. Should I just do 31? Are there no other questions? Like maybe 13 with a square root, or 49? Look through these questions. 45, 49, 45, 49. 45, 49. Okay, very good. I can do those. Look through these questions. Look for which ones are looking scary to you. 45 and 49. Okay. 53. Sure, we'll do 53. Follow these rules. The more you practice these, right, the better these are getting. So we'll do those, and then I'll do 31 as well. All right, so for 31, for that section in 31, what I wanted you to do, it says, find the slope of the graph at the given point. It says something about a calculator. Don't worry about that. We just want to find the slope. Find the slope of the graph of the function at the given point. Find the slope of the curve at the given point. So all that section 31 to 37 is you're finding the slope of the curve at a given point. When you see this phrase, slope of the curve, this phrase means the derivative. When you see that phrase, slope of the curve, that means you're looking for the derivative, right? The tangent slope. Tangent slope of a curve. When it tells you at the given point, this means you're going to plug in an x value. You're going to be given an x value, and you're going to find the slope at a particular spot. So you find the derivative, and then you plug in an x value. At the given point means plug in an x value. And that's true for all the equations that you had in that section. Number 31, the function was 8 over x squared. And the point was 2, 2. So we're going to find the derivative, and then we're going to plug in the x value right here into the derivative to find the slope. So find my derivative, do the d dx of the whole problem. 8 over x squared becomes 8x to the negative second power because we want to use our power rule. Put the variable in the top, and then do the derivative, bring the exponent down. We get negative 16 x to the negative third power, which is negative 16 over x cubed, right? And then I plug the 2, this is the derivative, this is f prime. And then I plug this 2 into my x to find the derivative at that point. I want to find f prime at 2, at that location. Right? I want to find the derivative at a given point. F prime at the location of 2, that means I just plug in the 2. Negative 16 over 2 cubed, which is going to be negative 16 over 8, which is negative 2. And that is my slope. That is the slope of the curve at x equals 2, or at the point 2, 2. This is a point, this 2, 2 is a point on f. This 2, 2 is a point on the function. I'm finding the slope of that point on the original function. The slope is f prime. So this is the original point on the function. At that point, I find the derivative, I find the slope. And that's how you would do it for all those questions. Find the derivative, plug it in, find the slope. Having an understanding of that is going to be key for doing a lot of these questions. For the next section, 41 through 53, you just have to find the derivative. So we said 43. What did we say? 43. No, 45, 49, 53. 49 and 45. So 45. Let's try 45. G of t. I'm just finding a derivative now for these questions. Nothing to plug in. Right? There's no point that it's given me. Just plugging in 3t squared plus 4t minus 8 over t to the 3/2 power. Ah, complicated. So for this one, we want to find the derivative. When we're doing derivative, I want to make sure I have each independent piece. So I'm going to give the 3/2 power, I'm going to separate it out into different problems. 3t squared over t to the 3/2 plus 4t over t to the 3/2 minus 8 over t to the 3/2. Give it to each one, separate my problem out into pieces so that I can do the derivative of each one. Now, when I have a variable over a variable, right, I've got my t squared over t to the 3/2. When we're dividing variables like this, what do we do with their exponents? How do their exponents interact? With this division, what happens with exponents? What do we do with them? How do they like combine together? What's happening here? When I divide, what happens to exponents? Like if I had x to the 5th power divided by x to the 3rd power, what does that become? X to the fifth over x to the third becomes what? X squared. Yes. Why does it become x squared? What are we doing to the 5 and the 3? How are we combining these together? Exactly, we subtract them. So you do the same thing with these exponents here, the 2 and the 3 halves. You're going to get 3t to the power of, well, what is 2 minus 3 halves? 2 minus 3 halves, let's see, that's a 4 over 2. 4 over 2 minus 3 over 2 is 1 half. There's your exponent. Subtract those exponents, get a new one. Plus, that's a 1 minus 3 halves, 4t to the power of, let's see, 1 minus 3 halves, that's going to be negative 1 half. Minus 8, oh, that's negative exponent on its own, t to the negative 3 halves power. So you just subtract the exponents, make them into a new exponent, single exponent. It's just numbers. Don't be scared. Don't be scared. It's just numbers. 2 minus 3 halves. I mean, you're all grown-ups. You can do this. You're big boys and girls. I believe in you. 3 to the 1 half. Now I want to do my derivative. Now that I've simplified my equation, I've simplified it all into stuff I can do. Now I do the derivative of each one, and I just follow the power rule. 1 half goes in front. This is going to be 3 halves. T to the negative 1 half, because 1 half minus 1, negative half. Plus, fraction goes in front. Well, that's going to be negative, actually. Negative 4 over 2, which is just negative 2. T to the negative 1 half minus 1 more is negative 3 halves. Right, fractions. Figure that out. Bring this in front, negative 8 times negative 3 halves, that becomes a positive. 3 times 8 over 2, that's going to be 4. 8 divided by 2 is 4. 4 times 3 is negative 12, so that's going to be positive 12. T to the negative, let's see, negative 3 halves minus 1 is negative 5 halves. Negative 3 halves minus 1 is like minus 2 over 2. 3, 2 makes negative 5 over 2. Figuring out all those exponent situations, subtracting and adding all these fraction exponents. Fun with fractions, everybody. And so I have our derivative. If I rearrange my negative exponents back to where they belong, 3 over 2. I could just say t to the 1 half. That's fine. Or I could say the square root of t. Either one is the same thing. These are the same. Square root of t of t to the 1 half. If you want to leave your exponents as fractions, that's perfectly fine. You will not get any points marked off on the AP test. Completely fine. Fraction exponents, they don't care. They do want your exponents to be positive, however. So you need to make sure you do that. 2 over t to the 3 halves plus 12 over t to the 5 thirds. They do want your exponents to be positive, but they do not care if they are fractions. And that's your answer. Kinda ugly looking, but it's okay. We deal with these things as they are. Okay? The book answer is different than this. Oh, really? Let's see. What is this? 2.2 number, what is that? 45? 2.2. 2.2 number 45. Let's see. Section, chapter 1. I would ask you to write it out, but it's probably complicated. 2.2, here we go, number 45. Oh, well, I mean, sure. So the book answer is they simplified it a little bit. It's the same answer that we have here. It's just they combined all the fractions back together into one, and they made the denominators all the same. 5/2, yeah. Oh, what if I have 5/3? Hold on, 5/2. 5/2, everybody. 5/2. It's the same. The book answer is a different arrangement of these same things. So I'm not too concerned about your process. I'm going to look through to see if you did it correctly. As long as you did all the steps correctly, your answer is fine. Yeah, we could combine like all these, make them into 5/2 and give each one. It's just we could make it a little messier, but the way we have it, this is totally fine. A completely acceptable answer for the AP test, no problem. Why does the 8 have this -3/2 right here? This you're asking about? Are you asking about the very first part right here? Why does this 8 have the t to the 3/2? 8 t to the 3/2, -3/2 power. Bottom part. Oh, down here? Where? Down. Here. Here? Here. This here? 8t to the -3/2. So this comes from this equation here, right? It was 8. This t to the 3/2 is on the bottom. I put the t to the 3/2, I made it -3/2, brought it to the top. That's a t. That's a t. I don't know, maybe it looked like a plus sign. Yeah, in the book it has a different answer. It has 3t to the 3/2 minus 2t to the 1/2 plus, 4, and that's a 24, over 2t to the 5/2. This is the same answer. These are the same. It's just simplified fractions. So don't worry about the book answers. I don't know. I guess it's hard to check if the answers are all complicated, right? I can see that being challenging. If there's a problem in the text, if you want to, what we can do is if there's a problem where you're not sure if you did it right, text me on Remind, show me the answer, and I'll tell you if you did it right or wrong. If your answer is different than the book answer, text me on Remind and show me what you got. I'll let you know if you're doing it okay. Let's do 49. 49 is square root of x minus 6 times the cube root of x, minus 6 times the cube root of x. This was f of x. So if we want to find the derivative of this, we have no fraction to deal with. We don't have to simplify anything. Maybe we want to change our radicals into fraction exponents. So I do d dx of the whole thing. This is going to become, I'm going to change it to fractions. Square root is x to the 1/2 power minus 6x to the cube root, right? Basically, with radicals, it's n root of x to the m, means your radical becomes x to the m over n. This is how you do fraction exponents. So the bottom part, right, the n, the outside radical, the radicand, is the denominator. And any exponent you have on the inside or the outside, any exponent part, is the top of the fraction. Regular exponents are the tops of the fraction. The radical part is the bottom of the fraction. This has a 1 on the inside part and a 3 on the outside. This has a 1 on the inside. The square root by itself is always a square root with a 2. So this is a 2 radical. 2. This is a cube root, so we're going to have x to the 1/3 power. So we do the derivative of this. Follow my power rule. Bring the 1/2 in front. I'm going to have 1/2 x to the negative 1/2 power. 1/2 minus 1 is negative half. minus, let's see, bring this down. 1/3 times 6 is 2. 6 over 3, right? 6 over 3 comes to 2. And 1/3 minus 1. Let's see, 1/3 minus 1, that's minus 3 over 3. 1 minus 3 is negative 2 over 3. X to the negative 2/3. Whatever the exponent is, just subtract it by 1. Deal with the fractions. 1/3 minus 3/3 is negative 2/3. Deal with the fractions like you would any other fraction. And our last step, we have to make our exponents positive. 1 over 2x to the 1/2 minus 2 over x to the 2/3. And that's your answer there. Again, they probably have a different answer in the book, right? Let me check. 49. Oh, no, that's right. Great. They have a square root instead of a 1/2. That's fine. Same thing. Okay? So this power rule, you see this is like the main rule. Here we're using this power rule, using radicals, using fractions, dealing with the exponents, bringing them in front. Sometimes when you have the 1/3 times a 6, you get simplify it and make it a 2, right? Do the division. Work your situations out with all your exponents as best you can. And if it's not exactly the same as the book, if you're concerned, text me on Remind. Text me a picture of what you did. I'll tell you if you're getting it right. My goal is not to hide from you any information. My goal is to tell you what you're doing, if what you're doing is right, as often as I can. I don't want to. I'm not going to hide anything from you. I don't want to I'm not trying to, I don't know, trick you into not knowing what you're doing. I want you to know what you're doing. I want you to have that confidence. So send me messages. I will happily answer any questions you have to make sure you get 100% on any homeworks, anything like that. That is my goal. I want to teach you. I don't want to, make you not know what's going on. So if you're wondering if something's right, text me. I'll let you know. All right, 53. Should we do 53? Last one. Y equals 1 over 3x to the negative second power minus 5 cosine x. So with this one, we have this weird fraction with a negative exponent situation. What can we do about this? First off, the exponent's negative. What does that tell us about this exponent, about this piece here? What does this negative exponent tell us about the piece? What should happen to it? What should we do with it? What does a negative exponent mean? Any ideas? What do we do with this negative exponent? No one knows? Not sure? What did we do with these negative exponents? What did we do with this negative 1/2? What did we do to it? X to the negative half. Flip a do, right? Yeah, exactly. Adrian, flip a do to the bottom. It was on the top. We flipped it to the bottom. And that made it positive. Negative exponents are in the wrong place. Negative exponents, whenever you have a negative exponent, it is in the wrong place. You flip a do. So we have a negative exponent down here. When we flip it, it means this negative exponent is in the wrong place. It's in the denominator, and it doesn't belong there. So we're going to make this 3x squared. Put it to the top. Negative exponent's in the wrong spot, put it to the top. 3x squared minus 5 cosine x. And now I can just do some simplifying, right? Give each one these squared. This is going to be 9x squared minus 5 cosine x, right? Just distribute the squared, simplify outright. We cannot do our power rule with this parenthesis here. We can't do the power rule with the parenthesis or the squared. It needs to be given to each piece. I want it simple and uncomplicated, unburdened by parentheses. Parentheses make things a little bit weird. The order you do things in, right? We want to simplify, make sure everything is all laid out plainly together, all in a row. So if you have parentheses, you got to distribute that exponent, or if it's something like x plus 2 squared, you got to do x plus 2 times x plus 2. You have to factor it out. X squared plus 4x plus 4. Factor it out. Make sure you get it all plain and laid out in a row before you start doing your derivative. You don't want to deal with any parenthesis nonsense when your derivatives are happening. Nope, no parenthesis nonsense. So negative exponents are in the wrong place. Flip-a-do, move it up here. Do the squared, we get this. Now we just do the derivative of this whole thing like regular. Bring the exponent down, that's going to be 18. X to the first power minus 5 stays in place. What is the derivative of cosine, everybody? I need to do the derivative of my cosine. What's the derivative of cosine? Is it like this? Negative sign, yes. So I have a negative here. Negative and negative sign makes this a plus 5 sine x. And that's my answer there. Okay? These derivative rules help us to quickly solve derivatives for more complicated situations, more complicated problems. And that was what I wanted you to practice last time in this assignment. Okay? So practice these derivatives, use this power rule, all these things here. Other questions? Mister, why did you put that number there? Where did that squiggle come from? What does this mean? Keep in your mind about the rule of fraction exponents. Deal with these radicals. Negative exponents go in the wrong place. Feeling good? Feeling more confident? Practice it. It'll be okay. I'm going to move on. 2 more rules. 2 more rules we're going to do. So I'm going to do a new page here. We're going to do 2 more rules. So this is going to be 2.3. More rules, more derivative rules. Two more rules we're going to talk about here to give you a chance to practice. We're going to do a multiplication rule and a division rule, right? We did an addition subtraction rule, right? Addition subtraction works fine. But the one rule we're going to talk about, first rule, is called the product rule. Product rule. Product rule. When 2 functions, functions are multiplied together. So, for example, if you have an equation that's like, how do I say? Okay. Something like, if you have f of x, some equation f of x, times some other equation g of x. Some examples of this are things like x squared plus 3 times the cosine of x. This is a situation where you have two separate pieces, two separate functions, multiplying each other together, right? Or x sine x. This is a function where two pieces are multiplying together. This x part is like f, and the sine part is like g. And they're multiplying each other together, f times g, right? Here, this is like f, this piece is like f, and this piece is like, g. Two different distinct functions multiplying each other together. There's no easy way to do a derivative of this situation, right? You can't just do the derivative of one times the derivative of the other. It's a little bit more complicated than just take the derivatives of each. It's a little bit more complicated. Multiplication throws in some messiness. So the way we do this is, if we do the derivative, d dx, of two functions multiplying each other, f of x times g of x, it becomes this situation here. You do the derivative of each piece one at a time. So what I mean is, you do the derivative of the first piece, you find the derivative of the f, and you leave alone the g. So you do the derivative of the f piece times the g, and you leave the g alone. Only do the derivative of the first part of f times, leave the g part alone. They're still multiplied. You just leave the g part alone and do the derivative of f. Derivative of the f part times g. Okay? And then you add to that, leave the f part alone, times the derivative of the g part. And so there's two pieces that you add together. F prime g plus fg prime. F prime, derivative of the first times the second, plus derivative of the second times the first. First times derivative of the second plus second times derivative of the first. You do each derivative one time. You do the derivative of f, derivative of the first one, times, leave the g alone, plus derivative of the second, times, leave the first one alone. So the phrase is the derivative of the first, derivative, or you can say derivative of the first times second, plus derivative of the second times the first. What is it? Plug plus. Derivative of the first times the second plus derivative of the second times the first. F prime g plus g prime f. F prime g plus g prime f. F prime g plus g prime f is the rule for the product rule. F prime g plus g prime f. So for example, if you're given an equation like, I don't know, what's a good one? 3x squared sine x. 3x squared sine x. Okay? My f is 3x squared. My g is sine x. So if I do the derivative of this, I'm going to say f prime g plus g prime f. I'm going to do the derivative of the first times the second plus the derivative of the second times the first. So what am I going to get? Do d dx of this whole thing. I do the derivative of the first part, so I'm going to do that in red. The derivative of my f, well, that's the power rule. Take the 2 down in front, make it 6x. And I leave the sine part alone, times the sine of x. I didn't do anything to the g part. I left it alone. Did the derivative of the f prime times g. Plus, now I do the derivative of my g part. The derivative of sine is cosine. Times, I leave the f part alone, 3x squared. So it's f prime times g plus g prime times f. Right? I do the derivative of each one time, leaving the other alone. And I can do it now. I want to do a little rearranging of this to make my parts sort of lined up. I'm going to do the 6x sine of x plus, I'm going to put this 3x squared in front, 3x squared cosine x. I just like to rearrange it to be in the proper order. But either way is fine. It's helpful sometimes to rearrange it and make it a little bit sensible. Okay. Let's try it one more time. What if I have a function f of x is square root x and g of x is, let's call it 2x squared plus 3x plus 1. And I want you to find the derivative of f of x times g of x. So this problem is presented in a slightly different way. It's presented slightly differently. We have the functions kind of separately listed over here and here, but it asks us to find them with the product rule, the multiplication of f times g. So we're using the f and the g functions. We're just sort of using them. We're looking at them separately from the equation, right? They're like different parts. So it's presented a little differently, but it means the same thing. We're still using our product rule because we're still multiplying these functions together. And these are the functions, so we're going to do the same rule we have. We're just going to slot these in, f and g. We're going to slot them in where we need them. So my derivative is, remember, it's f prime g plus g prime f. So I'm just going to slot these in where I need them. I'm going to do my derivative of f and the derivative of g and put them all together. So here's f, square root of x. What is my derivative of f? If f is square root of x, f prime is equal to what? What's my derivative of the square root of x? Well, that's the same thing as x to the 1/2. And so I bring my power rule. I have 1 over 2 root x. It's 1 over 2x to the negative 1/2 power, right? Which I just make into 1 over 2 root x. Hopefully, after you've done this a lot, you start to memorize these square roots, right? Square root of x is 1 over radical, 1 over 2 root x. It's one of the derivatives we'll see a lot. So there's my f prime. I'm going to put that into my equation. 1 over 2 root x times g of x. So I'm just going to plop g of x right in here. 2x squared plus 3x plus 1. F prime times g. Plus, okay, now I need g prime times f. So my g equation was 2x squared plus 3x plus 1. What is my g prime equation? It's helpful to write these out so you know where to find them when you need them. All right, somebody in the chat, you can type this easily. What is the derivative of g? What is g prime? What's the derivative of this equation here? Pretty easy to do. Power rule. 6x plus 3, close. Not 6x plus 3. This is a power of 2 up here. Yeah, 4x. Very good. 4x plus 3. Bring that 2 down. 2 times 2 is 4. Power becomes a 1. 3x. And the 1 disappears. 4x plus 3. So my g prime, 4x plus 3, times f, my f equation is the square root of x. And there you go. Just slotting in the pieces where you need them. You have all 4 pieces here. Slot them in where they belong. F prime g plus g prime f. All right? Now that you know your derivative rules, you can find the derivatives of things pretty easily. So that was the power rule. Rule number 1. Power rule, f prime g plus g prime f. Rule number 1, our power rule. Or product rule, rather. Product rule. Rule number 2. Well, if we know how to do a derivative with multiplication, we got to figure out how to do a derivative with division. This is the quotient rule. Quotient rule. Quotient rule, you find a derivative of when equations are divided from, how do you say? A derivative of a division. Find derivative when equations are divided. So this is like f of x over g of x. And so this is things like x squared plus 3 over 2x squared plus 5x minus 1. Something where you have 2 equations divided by other. Right? 2 equations divided by each other like that. Or you've got x squared over sine of x. Right? Or you've got, what's some other ones? Like, even things like, I don't know, 3 minus 1 over x over the cube root of x squared. These are 2 functions that you can find the derivatives of each independently using this quotient rule. So the quotient rule says if you find the derivative of f of x over g of x, again, the same kind of thing. You're doing derivatives of different parts at different times. So follow along carefully, write this down. It's going to be g of x times f prime. Let me just do g times f prime. Let me just do g as x business. Just what's happening here? Come on, computer. So you do the bottom equation times the derivative of the top. So it's g times f prime minus f times g prime. So it's kind of like the product rule, right? You do the bottom one times the derivative of the top. The bottom equation, you bring it up, times the derivative of the top equation, minus, quotient rule has a subtraction, minus the top equation times the derivative of the bottom. So it's the bottom times derivative of the top minus the top times derivative of the bottom. And that whole thing is divided by the bottom equation squared. So this is the quotient rule. Quotient rule. When you have two functions dividing each other, you take the bottom one times the derivative of the top minus the top times the derivative of the bottom over the bottom one squared. And there's a fun little phrase that helps you remember this. Fun little phrase that can help you remember the order here. So it's like this. It's low d high, minus, write the word minus, high d low, low d high minus high d low over low squared. Low d high minus high d low over low squared. Low d high minus high d low over low squared. That's how you're going to remember this quotient rule. Right? It's g low d high, right? G times f prime, low d high, minus high d low, f times g prime, low d high minus high d low over low squared, over g squared. And that's our quotient rule. Let's give it a try. Let's say I have a question like, what's a good one? If f of x is some equation 5x minus 2 over x squared plus 3. Find f prime. Find the derivative of this. So when we do the derivative of this quotient here, of this derivative, we're going to do low d high minus high d low over low squared. So this is low, and this is high. So low d high. So I take the low part, I leave it alone, that's going to be x squared plus 3. It's low d high. So what is my derivative of this upper part? Derivative of 5x. What's my derivative of 5x? Low d high. Derivative of 5x is just 5. Low d high minus the high equation, I leave it alone, 5x minus 2, high d low. What's the derivative of my bottom equation? Low d high minus high, I left the 5x squared, 5x minus 2, left it alone, times the derivative of the bottom equation, x squared plus 3, the derivative of x squared plus 3 is 2x. That's my power rule. Bring the 2 down in front, get rid of the 3. So it's d high minus high d low. Right? That's low d high low times the derivative of the high, minus high d low. All over the low part squared. So if I square an equation, if I have this x squared plus 3. If I square that, I'm just going to put it in parentheses, x squared plus 3, and square it. And that's fine. This is done. Well, we should really simplify. Hold on. We should really simplify. Our basic part is done. We just now need to, all the rest is just cleaning up. So if I simplify this, let's see, I can distribute my 5 maybe. I'm going to have 5x squared plus 15 minus, if I distribute this 2x, I'm going to get 10x squared minus 4x over this bottom part. I don't want to deal with that, so I'm going to leave it alone. That's fine. Distribute this negative part. I'm going to have negative 10x squared plus 4x. So let's see, I'm going to have negative 5x squared plus 4x plus 15 over x squared plus 3 squared. And that's my simplified answer. Right? 5x squared minus 10x squared. Combine like terms. This one, 5x squared minus 10x squared is negative 5x squared. 4x, right? I distribute that negative, get a positive 4x. And this 15 from 3 and the 5. All those pieces there. So that's my simplified version of this equation here. So we followed our rule, low d high minus high d low over low squared, simplify our problem, and get our final answer. Let's try this again. One more, and then we're done. What if my function is square root of x over cosine x? No. Hold on. Let me fix this. Cosine x over square root. I like that better. What do I do? Same thing, low d high minus high d low over low squared. So low d high, my low is square root of x. The derivative of my upper part, low d high, derivative of cosine is negative sine. So it's going to be negative of the whole equation, right? Negative sine of x. I put the negative in front of the radical part because it's these two are multiplying together. So the whole piece here is negative. And if you want to think about it like this, what you're doing is radical x times negative sine of x. I just put the negative in front. Just makes it easier. Like that. Negative sine of x. Right? So low d high, that's low d high, minus high d low. Cosine stays the same. The derivative of radical x, oh, there's another radical, 1 over 2 radical x. Hopefully you have these kind of things memorized. Whole thing divided by low squared. Radical x squared on the bottom. All right, so that's our low d high minus high d low over low squared, our complicated situation. Now, simplify. What can I do? Well, I really can't do much to the x root x sine of x. That stays the same. And I really can't do much to this cosine. I could maybe like cosine of x over 2 radical x, like this. Sort of combine them together. But the bottom part, square root of x squared, that just becomes an x. Right? The squared part and the squared cancel out. So this is kind of my final answer for that one. That's okay. Low d high minus high d low over low squared. I combine this cosine radical thing here. I can multiply these together, right? Because this cosine is like cosine over 1, right? Combine these together, make this one thing. And that's kind of the most simplifying I can do. I could maybe multiply by 1 over x everything. That's kind of not really key. This is fine. Good enough. All right, everybody? Questions? I lied. I want to do one more example. Sorry, everybody. I know we're running out of time. Whoa. Let's combine these together. What if I have some function that is 1 over x plus 1 times x squared minus 5? If I have some function like this, I want to find f prime. Well, now I have a product rule where I have two pieces multiplying, and one of my pieces I need to use the quotient rule. I have a product rule and a quotient rule together. So I'm going to have to use my whole situation, right? I use the product rule for the outside part, and then when I get to the derivative of the inside, I need to do the quotient rule for this inner derivative. Product rule was first times derivative of the second, fg prime plus gf prime, for second times derivative of the first. So leave the first one alone. 1 over x plus 1 times derivative of the second is 2x. So I'll use my product rule, and then quotient rule sort of inside the product rule, right? This is going to require the quotient rule. The whole thing is going to require the product rule. So do the derivatives you know how to do when you need to do them. These parts and these pieces are going to combine in all kinds of different ways. So first times derivative of the second plus the second part, x squared minus 5, times the derivative of the first. This is going to require a product rule, a quotient rule. Low d high. Okay, so low is x plus 1. The derivative of the top part, what is the derivative of 1, everybody? D high. What's the derivative of 1? Derivative of a constant is a 0. So low d high is x plus 1 times a 0. Minus high d low, 1 is the high part, the derivative of x squared plus 1. What's the derivative of x squared plus 1? Derivative of x is just a 1. X plus 1 prime, right? The derivative of x, the 1 in the exponent comes down, becomes a 1. 1 times 1 is 1. X goes away, it just becomes a 1. Over x plus 1, the bottom part, squared. So follow your derivative rules, right? Low d high minus high d low over low squared. Now I can simplify a little bit. This is going to become, okay, I guess this is 2x over x plus 1 plus x squared minus 5 times. This times 0 is going to go away. 1 times 1 is going to be 1, so it's going to be negative 1 over x plus 1 squared. I could go maybe a little bit further and say 2x over x plus 1 plus, minus rather, now minus is it's negative, minus x squared minus 5 over x plus 1 squared. that would be it. So lots of situations where you're going to do some derivatives, some chain rules, some problems like that. Your homework. It's 2.2, so 2.3, section 2.3, page 129. 5 through, what did I say? 21. Odd. Not very many. But enough to practice. Five to 21 odd. Practice product rule, chain rule, your derivative rules. We will go over this again on Monday next week. Send me messages on Schoology. We can meet. I'm available for meeting. I have office hours. Let me know. But give these a try. Practice these. Come up with some examples. And that's well over time for me. Thank you for staying, everybody. Type goodbye in the chat. Once you type goodbye, you're free to go. I will see you all next time. Have fun this weekend. Bye, everybody.